Stoichiometry and conversion factors. Converting using dimensional analysis and mole ratios. In this video, we're going to focus on using conversion factors to convert between different units. So we're going to focus on grams, moles, and numbers of atoms, but you can use these exact same concepts to convert from any unit to any other unit as long as you have the conversion factors. We'll then use mole ratios to convert between products and reactants. And we'll combine all of these topics to answer some more complicated problems. So for any given unit that's in the numerator or the top, or in other words, just on its own, you can cancel it out by dividing. So for example, let's say that we want to convert 5 minutes into seconds. Well, we want minutes to go away, and so we put minutes on the bottom. We want seconds to happen, so we put seconds at the top. And then our units will cancel. Leaving us with only seconds, because the minutes on the top cancels with the minutes on the bottom. This is the opposite if you have something in the denominator. So for instance, if we want to convert something like meters per second into meters per hour, we now actually are going to be doing the reverse. Because right now, seconds is on the bottom, but we don't want seconds to be there. So since we're dividing by seconds in the initial number given, we need to multiply by seconds to cancel it. And that leaves us with hours in the bottom, which is where we want it, which cancels to give us meters per hour. So now let's do this with mole conversions. So we have 1 mole is equal to 6.022 times 10 to the 23rd atoms. Think about moles as being similar to something like a dozen. So if you have 1 dozen eggs, you have 12 eggs. If you had 5 dozen eggs, you have 60 eggs. This is the idea behind a mole. It's just a number of atoms. And then we use this because it lets us talk about things in numbers that are simpler to deal with, as opposed to have to constantly say times 10 to the 26th, times 10 to the 29th, all of these very large exponents. So if we want to know how many atoms are in 8 moles, we'll take 8 moles. We have moles on top right now, and we don't want that. We want that on the bottom so that it'll cancel, so that we put atoms on top. And now we know that we have to multiply by 6.022 times 10 to the 23rd because atoms are on the top. And this leaves us with our number of atoms. If you do this consistently, you'll never have to memorize when to multiply or when to divide, because you'll just know, oh, I'm going to put moles on the bottom to cancel it, or I'll put moles on top if it was on the bottom, and vice versa. So now let's talk about mass conversions. Mass conversions we're going to do using the periodic table. So we're going to use the periodic table to find conversion factors for this. 1 mole of a species is equal to the molecular mass as shown on the table. So for instance, here in this very select subset of the periodic table, we have 1 mole of hydrogen is equal to 1.0079 grams. So for example, let's say that we have 1 gram of lithium in a closed container. Let's calculate how many moles are present. We have 1 gram of lithium. We can divide by 6.941 grams, and I get that from the periodic table. That many grams are equal to 1 mole, and so 1 mole goes on top, and we get our number of moles of lithium. As usual, this is just one piece of many, many, many different, more complex problems. So now let's use chemical equations to add in something called a mole ratio. So our coefficients that are in a chemical equation act as our conversion factor between species. So these can be for number of atoms or for number of moles. So let's take an example. If a plant reacts 10,000 molecules of carbon dioxide, how many molecules of water does it need? So we look at our ratio here, and it's 6 to 6, or in other words, 1 to 1. So if we have 10,000 molecules of water, and we want to know how many molecules of carbon dioxide we have, or vice versa, we say it's a 1 to 1 ratio. And so for 10,000 molecules of carbon dioxide, you need the same number of water, or 10,000. Let's take another example. Let's say that we have 3 moles of carbon dioxide. How many moles of water is it going to need? Because everything is a 1-to-1 ratio with carbon dioxide and water here, if it has 3 moles of carbon dioxide, you're going to need the same number of moles of water. Continuing on with this. That slide got in there twice, just get rid of that. Okay, so now we can combine lots of these together. So let's take a different example that's a little bit more complex. For a plant to photosynthesize 1 gram of glucose, how many grams of carbon dioxide does it use? So if we want 1 gram of glucose, how many grams of carbon dioxide do we need? So now we're converting in between reactants and products, which is a little bit different, and also between grams and grams. You can't convert directly between grams and grams. You have to go through moles first. And so let's come up with all of the information we need first. First off, we're going to need to get from grams of glucose to moles of glucose. So we're going to need the molecular mass of that. So we have that. We can add that up from the periodic table. I trust that you can do that part. We can do the same thing for carbon dioxide because we're going to need to convert between moles and grams of carbon dioxide. And so that too from the periodic table. And then lastly, we need our molar ratio between our 2 species. So 1 mole of glucose is equal to 6 moles of carbon dioxide. And those are from the coefficients. So now that we have all of that combined, we can put those together in a way that cancels out the units. So we need to pick our starting point. It's usually what's given. So in this case, 1 gram of glucose. So we'll start with 1 gram of glucose, and then we're going to cancel that by using the molecular mass. And that will leave us with our moles of glucose. Once we have our moles of glucose, we cancel that out using the mole ratio. And so we'll put our moles of glucose on the bottom and our moles of carbon dioxide on top. From here, we need to convert between moles and grams of carbon dioxide. And so we use our molecular mass to put our grams of carbon dioxide on top and our moles on the bottom. We can double check that all of our units cancel. Our grams cancel here, our moles cancel here, our moles of carbon dioxide cancel there, leaving us with grams of carbon dioxide. And so we're all set. So now we just type that into our calculator to get our answer. We stuck with very chemical-related versions of this because that's what we're going to be going into a lot in the following chapters, but you can do this with any unit. You can work through and just cancel units until you get to what you want. And when you get into some of the harder problems in gas laws and electrochemistry and things of that, you'll be doing really complex versions of these. So in summary, we can use conversion factors to convert between units. Anytime that you have a unit that's in the numerator, you cancel it by putting it in the denominator. Anytime you have a unit in the denominator, you cancel it by putting it in the numerator. We can use mole ratios to convert between products and reactants. And we can use the molecular masses on the periodic table to convert between grams and moles.